Hello everyone, myself Hariom Mehta. I am currently pursuing my Masters MSc in Physics from Indian Institute of Technology, Jodhpur. Before this, I have been completed my Bachelor BSc degree from the Government Holkar Science College Indore with three major subjects: Mathematics, Physics, and with Computer Science. I have been completed my schooling from the Jawahar Navodaya Vidyalaya Multan Dhar in MP. I have some teaching experience as a teaching assistant for the students of the grade 9th and 10th which enhance my teaching skills and understand me to how to handle the students and how we can improve our capability to engaging with them and how we can deliver efficiently our topics to them. I am currently working as a placement coordinator which enhance my communications connectivities and the leadership skills. I secured all India rank 887 in IIT GEM 2023, which proves my the problem solving skills of my. I am very interested in teaching, especially the physics subject, and I want to go for teaching as a career for me. I want to give some knowledge to the students and to the our juniors or the societies. I also want to know about them, that what they want to, and motivate them for the exam like JEE and NEET. SpeedLab is the very good platform because I go through the SpeedLab sites. The content which is provided by SpeedLab to the students is well structured and easy to understand and very engaging with the students. It's make easier learning journey of the students, and I also want to join this because the commitment of the speed lab is blazing blending teaching with the modern technology is aligned with my passion and interest, because I also want to teach the student with the new modern technologies. So I have also experience in teachings. So if you consider, then now I would like to start our today's topic, capacitor. I want to teach you a capacitor. So first we have to know that what is the capacitor. First we have to know what is the capacitor, and after that we note the types of the capacitor and the many things. So first we have things the what is the capacitor. So capacitor comes from the word capacity. As we all know that the capacity of any object is that how we can store anything in it. Means for example, if we take a beaker here and want some water into it, there is a certain limit up to when it can be filled up to this limit we cannot fill more water in this beaker. So this is the capacity of this beaker. Just like this, in our electrical or electrostats, we want to store charge in our devices. So for this we introduce our capacitor. So capacitor is nothing but an electrical device. Capacitor is nothing but an electrical device which stores electrical energy, which is used for the store electrical energy. So it is an electrical device used for storing electrical energy. In form of electrical charge. Means it stores electrical energy in the form of the electrical charge. Without storing the charge you cannot store electrical energy. First you have to store the charge, then the electric field is formed there and the electric energy is stored in this capacitor. So just like this. But there is a question in our mind that there is also a battery which is used for the electrical electrical store electrical energy. So why we need to this capacitor? So because there is a very big difference between the capacitor and the battery. As we know that the battery also store electrical energy, but when we require a sudden energy or we require a sudden electrical energy, it cannot be provided by the battery. So we have to need a capacitor which provide an immediate energy. It's release energy, electrical energy within a within very less time, within very less time, or suddenly, or can say suddenly. So this is the our capacitor that which cannot be do work by the battery. So it means when we charge a capacitor firstly, and then when we require or we need to it the energy, it boost directly to the our, just like our fan, we want to initiate our fan. So first it store the energy from the battery and just release with the suddenly, which has to start our fan or motors like the equipments. So after that there is another term we have to introduce, that the capacitance. So what is this capacitance? As we all know that the resistor have some specific resistance, which means resistance. What is resistance? So resistance is the ability to oppose the current of any resistor. Means how resistor can oppose the current, it's given by the resistance. So just like this, how energy is stored by any capacitor is given by this capacitance of this capacitor. So it is nothing but the ability to store electrical energy by the capacitor. Means how much energy can be stored by the capacitor, it is given by its capacitance. We can define it by C is equal to Q by V. For as of now we can directly put it here. If you want to how we can write this, so we can take an example, just like take a conductor and we want to charge it. So we take some positive charge from the infinity and put it on the in this conductor, and when we number of the charges are increases here, the potential difference between the potential also increases here. So the charge is directly proportional to the potential difference between this conductor and the infinite point hour. As we know that the our potential is k q by r, which is directly proportional to our charge. So from here we can write charge is directly proportional to our potential difference. So this charge, when we remove this proportionality constant, when we remove this proportionality symbol, then we add a constant which is a capacitance. So from here we can define this capacitance, and the unit of this capacitance is the coulomb per volt, which is given by, which is said as farad. This is our SI unit for the capacitance. So rather than this C is our constant things which is not depend on the charge of the capacitor or neither depends on the voltage of the capacitor. So take care of these things, that the capacitor is our constant thing. It's depend on only on the material of the capacitor and the dimension by the arranging of the capacitor. So our capacitor is constant. Means if you construct a capacitor once, their capacitance is defined already. After that, it cannot be changed. So now we are going for the types of the capacitor. That what are the types of the capacitor and how many there are types and how they are works, how it can be constructed. So first, which is the very simple or mainly used in our syllabus or asking question in the parallel plate capacitor. After this, there are two more capacitors in our syllabus. One is spherical and another one is cylindrical. Okay, these are mainly three types of the capacitor. So first in this video, I want to discuss about the parallel plate capacitor, that what is the and how it can be constructed, and what is the capacitance of this capacitor. So I want to discuss about this parallel plate capacitor. So parallel plate, as we know that there is a parallel plate, means from the norm we can say that there is a plate, this is a charge plate. When this charge plate is come in contact with the another conducting plate, its attract is negatively charged, or we can say the electrons towards it, and because of the force of attraction all electrons are aligned in this direction. Because of the repulsion of the force, the positive charge is in these directions. Okay, so when we ground this positively charged side, so this all charge positively charged are neutralized, and the negative, when we remove this thing, then these negatively charged are uniformly distributed to the all over the plates. So by this we can construct a parallel plate capacitor. Now we want to find the capacitance of this parallel plate capacitor. Capacitance of parallel plate capacitor. So we note that the capacitance of the any capacitor is Q by V. So for finding V, we have to define the electric field, because we know that the potential difference between the plates is depends on the electric field. So potential difference is directly, we can say that the potential difference is equal to the electric field into the distance between the two plates. Means this is the this. Matlab, we can say that the potential difference of any two conducting plates is given by this, which is studied previously. So and from here we can say that what is the electric field of these plates. So from a infinite sheet of infinite plate, the electric field is given by the sigma by 2 epsilon naught, where sigma is charge on the plate and A is the area of this plate. So we put this plate as closer to us, that as closer as possible, because when A is very large to D as compared to D, then we can consider this as the infinite plate. So we put it close to each other. So from here we can see that the electric field from the positive plate between to this point is sigma by 2 epsilon naught towards the negative sides, and from the negative plates is also from towards the negative plate sides. So electric field from the negative plates is also sigma by 2 epsilon naught. So by this we can say that the total electric field between the plates is sigma by 2 epsilon naught plus sigma by 2 epsilon naught, which is equal to sigma by epsilon naught. Okay, and when we put the sigma values q by a here, so our E net is now is equal to q by a epsilon naught. This is our total net electric field between the plates of the this parallel plate capacitor. So when we put this electric field in this formula, then the potential difference across the plate is given charge upon area epsilon naught into the distance between the parallel plate between the plates. So this is our potential difference between the two plates, and from here we can easily find the capacitance of our parallel plate. So when we put these values here, so charge upon q by q divided by a epsilon naught into d. So this is our capacitance, q से q cancel, then a epsilon naught divided by d. This is our capacitance. Means we can say that for the parallel plate capacitors, our capacitance depends on the area of the parallel plate of one plate and the distance between the two parallel plate and the medium which is filled in this between the plates is depends on capacitance. Means capacitance depends on all these three things. Okay, so from here we can see this, and also we can one more thing, that how many energy stored by this parallel plate capacitor. So energy stored in this parallel plate capacitors, we derive a formula for this. So what is the energy? First we have to think about the energy stored in parallel plate capacitor. Energy stored. Okay, so energy stored means how much we have to work done to charge these plates or charge this capacitor by a battery. This is called its work done or its energy. So means when we at initial time when one electron is go here, then is negatively charged, then another, then second electron, these things makes our capacitor charge. So by this we can say easily that our change in the work done is given by the potential difference between the plates and the change in the charge of the our plate. So from here we can easily find our electrical energy stored in the parallel plate. So because this is the change in the work done is also change in the energy of this parallel plate. So when we integrate it from 0 to W or 0 to V, then when integrate it, so it given by from 0 to up to Q charge. Means there is a certain limit now up to when it's only charge will up to the Q charge. So this is our limit. So then this is our work done, which is also defined as a U, is the energy of the capacitor, and we can also write V is equal to C is equal to Q by V. So here we can see we can write what we can write, V is equal to Q by C. Okay, so write this. So U is equal to Q by C dq. When we integrate this in respect to dq, this dq and dq is same. Okay, don't worry about this because there is a sign convention only. So when we integrate this, there is a q square divided by 2c. So this is our energy stored in our parallel plate capacitor. So this is enough for today. Thank you.